Hello everyone, I am Harsha Kumawat. I am currently working as a data science and business analytics intern at the Sparks Foundation. I have completed task 2 of my internship. Task 2 is prediction using unsupervised machine learning. The problem statement is predict the optimum number of clusters from the iris dataset and represent it visually. For this, the first step is import all the necessary libraries. So here I have imported Pandas, Seaborn, Matplotlib, uh, KMeans from sklearn.cluster and imported warnings to filter out any warnings. Next step is to import the dataset to basically load the iris dataset into the pandas data frame. To view that particular data, we are using head function that by default returns the first 5 rows of the dataset. Next is exploratory data analysis. Dot shape returns us the number of rows and columns. Here we can see that our data set consists of 150 rows and 6 columns. Dot info gives us the basic summary about the data. It gives us the range that varies from 0 to 149, that is 150 entries. It gives us the total number of columns, the column name, total count present on those columns, as well as the data type of each column. To check whether any null values are present, we are using isNull.sum function, and here we can see that no null values are present. Finally, extracting the independent variable. As we are using unsupervised machine learning algorithm, we don't need any dependent variable. So we are extracting sepal length, sepal width, petal length and petal width in our independent variable. We don't need our ID and species column in that. So once we have extracted our independent variable, another step is finding the optimum number of clusters. So here we are using elbow method, and it is one of the most popular way to find out the number of clusters. It basically uses the concept of WCSS, that is within cluster sum of squares. It is basically the sum of the squares of the distance between each point and its centroid within a particular cluster. So for each of the cluster, we are going to calculate the WCSS. And for the elbow method, we have to draw a elbow curve, and that curve is between the number of clusters and WCSS. So for all the number of clusters, we have to calculate the WCSS. So here we are taking the number of clusters ranging from 1 to 8, and then we are calculating the WCSS. So here we can see when we have the number of clusters 1, our WCSS is high. It is decreasing gradually when the number of clusters are increasing. We can view that with the help of this particular graph, and here we can see that on x-axis we have our number of clusters, on y-axis we have our WCSS, and we can see our elbow curve. So here we have to find out our elbow point. So wherever our elbow point occurs, that are going to be our optimum number of clusters. So here at point 3, we can see this is our elbow point, because it is where the WCSS doesn't decrease significantly with every iteration. So we can select 3 as our optimum number of clusters. So from the above plot using elbow method, we can see that our elbow point is at 3. So the optimum number of clusters here will be 3. Next step is train our model based upon the training dataset. So here we are creating the instance of the KMeans class with the number of clusters as 3, and then finally predicting our clusters. So here we can see that our model have predicted the 3 clusters, basically divided our dataset into 3 groups. We are working with KMeans algorithm, and it is basically the centroid based algorithm. So these are the centroid associated with those clusters. Now the next step is to visualize those clusters. So here the first cluster represents the iris setosa, the second cluster represents the iris versicolor, and third cluster represents the iris virginica, and also we have plotted the centroids associated with those clusters. So here we can see the 3 species of the iris flower, that is iris setosa, iris versicolor and iris virginica, and the yellow dots which are there, that represents the centroid of that particular cluster. In the summary section, I have included all the insights which I got by performing the above task. So thank you.